In this video, we're going to be reviewing Chapter 2, which is an overview of data mining in your textbook. It's going to go over a number of different concepts I'm going to kind of briefly talk about. I'm not going to go into great detail because we will be going into more detail in subsequent chapters, but just to kind of give you some familiarity with some of the terms that we're going to be using in this class. So the first one is supervised learning. And in supervised learning, we are using a data set that has a column or an attribute that is predicting something in that data set. So to give you an example, you could have a data set full of car insurance records. So you could have each record could be a person who has obtained car insurance, can have their demographic information, including annual income, their gender, their marital status, what kind of policy they have, what kind of car they drive, how many tickets they've received, how many accidents they've been in, etc., and then an attribute that either classifies them as a good or bad driver. That is an example of a supervised learning problem because we have this historical data, and now we're going to use algorithms that know how to work with that kind of data to predict future drivers in terms of whether or not they're good or bad drivers. So for those type of learning algorithms, we're talking about things like classification, naive Bayes, regression. Neural nets have the ability to do both supervised and unsupervised learning, but we'll be mainly working with classification and naive Bayes in this class, but you may see there are other instances of algorithms that can handle this kind of data. So this is really when you're trying to predict something and you know what you're trying to predict. In unsupervised learning, we are trying to figure out what that category is, or we're trying to group in such a way, but we're not actually trying to use training data that will tell us what it is we're trying to predict. So in this case, it's a little bit more open-ended. There's different types of algorithms for that type of learning where we're not actually giving it what we're trying to predict and the historical data for that. We have historical data, but maybe we have that insurance data, but now we don't have the good or bad category. We just have the data itself. So there's different things that you can use for this, including association rules, k-means clustering, k-nearest neighbors clustering, and also some of the pre-processing things that we do in data mining would be considered unsupervised learning for data reduction and exploration, also visualization, which we'll cover in Chapter 3. So again, in the supervised, under classification, the goal is we know what we're trying to predict. It's very clear. We have an outcome variable in our data that tells us what it is. It can be binary, meaning just two values, yes, no, good, bad. It could be multiple. It could be, poor, fair, or excellent. So it doesn't have to just be a binary classification problem. It can be more than binary. Each row is usually a case of some sort, either a customer, tax return applicant. We want data down at that very granular level. We don't want data that's aggregate. We want the actual individual records in our data, and every column becomes a variable in this. The target value, like I said, is usually binary. But it doesn't have to be. It can be greater than two values if needed for that particular prediction problem. In prediction, when we're trying to take the difference between prediction and classification is the outcome variable is categorical natures, and we're going to talk more about data types. But basically it means like yes, no, high, low, or high, medium, and low, but it's not numerical. If it's a numerical outcome, say income, and we're trying to predict somebody's income, we could have, that's not going to be a yes, no problem. That's going to be a numeric prediction problem. We use different types of algorithms for that. For instance, we can use regression analysis for that particular type of problem. So what problem algorithm you use depends on what problem you're trying to solve, whether or not you have supervised data or not, whether or not it's a supervised problem that you're trying to solve, and then also what kind of data do you have for that particular algorithm, and then that will determine what algorithm you're going to use. For unsupervised, we are going to be using association rules in just a week or two here, not too long. This is actually used a lot in grocery stores. It's also called market basket analysis. And basically what it's looking for is correlation. So it wants to see what goes with what. So, people who buy bread typically buy milk. That's kind of a common generic one. But the idea is that you're trying to find uncommon or interesting patterns of what goes with what and looking for that correlation. It's also called affinity analysis, and it's used in many different industries, but grocery stores are the most common. The other thing you'll be doing at some point with your data is, a lot of times there's a problem with data reduction. You have too much data, or you have too many, and especially not so much the number of rows, but typically the number of columns. The more columns you have, the much more complex of a problem it is, the much harder it is to get meaningful information from data mining. So sometimes you need to reduce the data and just take the ones that are most likely to be telling and giving you really good information. And there's different methods we use to figure out which categories we should keep and columns we should keep in a particular data set. And that's part of data reduction. That's typically unsupervised in nature. It's looking at that correlation again in order to decrease the size of the data set. The other thing we'll be working with is data visualization. That's in Chapter 3. That's looking at graphs and plots of data, histograms, bar charts, and this is really something that we do up front with data mining. We don't typically just go in, take a data set, and start data mining. We will usually do some kind of exploration first using this visualization technique so we get to know the data a little bit better prior to actually using any algorithms on the data. Next, I want to talk a little bit about the process of data mining. One of the things that's really important to understand about the process of data mining is that it is an iterative process, meaning that you need to go through these steps that are presented on here, and I apologize, I'm going forward and backwards, but I'm going to go back now. I'm trying to change the screen size, and I'm having some issues with that. Here we go. So you can see here they have 9 steps in here, and those steps typically will repeat themselves. So again, there's a lot of upfront work in data mining that a lot of people probably don't realize. First of all, you need to understand what is it you're trying to do. You need to become somewhat of as much as you can, an expert in that particular data that you're working with, talking to domain experts, making sure you're understanding what the data actually means, the source, where it's coming from, getting that data, which may involve random sampling because we may have too much data, so we may actually random sample it in order to decrease the size of the data, exploring it, cleaning it, and pre-processing. So cleaning and pre-processing really refers to looking at missing values and any reducing the dimensionality that I talked about earlier, as well as some other techniques that we use. Once we've done that and we've gone through that pre-processing of the data, we might reduce it, we might partition it, and then we're going to start looking into the tasks. And this is where we're talking about that supervised versus unsupervised. What's the most appropriate category that we're looking at? Below that, there might be, if it's supervised, we might be using classification. If it's unsupervised, we might be using clustering. And then choosing the specific techniques, which under classification, there's multiple types of classification algorithms, such as CART, C4.5, etc. Regression is also a classification, but that's working with numeric data exclusively. And neural networks can take both, but that could be unsupervised or supervised. So understanding that's down to the lowest level. Once we're done with that, then we know what algorithm we're actually going to be using for our data mining. You're going to run it, you're going to use the algorithm, get the results, kind of assess it. But as you're assessing it, you may find that, one, you're not getting interesting results. You could find that you maybe need to partition the data in a different way because it would be more interesting to partition it into smaller segments. So there's all kinds of nuances to that. As you do it, you may realize as you're reading the results that you could get better results if you change some things and then went through the process again. So it tends to be something that you do over and over and over again using different scenarios. So you're going to assess the results. There's metrics that we use to assess each of these different types of algorithms, different assessments for each one. You're going to compare it, see how accurate it is, and then see, is it something that you want to deploy, and you want to deploy obviously the best model that you can, that is going to be the best predictor if you're doing prediction, or if it's unsupervised, gives you the best results in terms of the clustering or association rules or whatever it is you're using to do the unsupervised learning. There's two major types of variables that we're going to get into more detail in another chapter, but right now the main thing that you need to understand is that there's categorical data, there's numeric data. So categorical is your religion, so you could be Catholic, Jewish, Muslim, Buddhist, or other, let's say, and then maybe another example of categorical is your male or female, or you're married, single, or divorced. So those are examples of categorical data. Those are used in certain ways, and we're going to get into the ordered and unordered later, but you can see what there's there, but there's specific names for those actually under those that we'll get into in a subsequent chapter. And then the numeric is just, there's numeric data, and there's different types of numeric data, two different types actually, that we'll talk about. But generally speaking, the algorithms we use don't go down to this continuous versus integer. They just want to know, is it numeric? So depending on whether or not you have numeric data, whether you have categorical data, will determine what kind of algorithm you're going to use once you get down to that task level. And sometimes there is pre-processing that needs to be done. If you want to say use classification, which can only use categorical, you might need to do some, and you have numeric data, there's things that you can do to convert that numeric data to categorical, and vice versa, from categorical to numeric as well. So in Excel Miner, which is an add-on to Excel, most of the algorithms can handle numeric data, and they will do something called binning or discretizing if needed to change numeric data into categories if needed. And then categorical is, most algorithms will use it as is, but some other algorithms you have to create what they're calling binary dummies. So for instance, if you have male, female, or yes, no, what they're saying is naive Bayes can handle that. The other algorithms need you to convert it to say male, female will become 0, 1. Yes, no will become 0, 1. If you have something with 5 categories, it will be 0, 1, 2, 3, 4, etc. So you have to kind of change it to a numeric value for the algorithm to handle it, even though it is still categorical data. It's just being converted to a number so that the algorithm can handle it. Another important concept in data mining is outliers. So that is something that we're looking for something that is extreme on the outside edge. It comes across a lot in clustering. It can actually really distort your results if you have too many outliers because it's changing the overall model. It's sometimes an important step in pre-processing, but other times it can actually be part of the actual process. Maybe you are trying to find that outlier because that's actually what you're looking for. For instance, the airport security screening, you're looking for that anomaly, that record that just stands out among the rest. So usually we want to get rid of those depending on the problem, but there are times where you're actually looking for those outliers. We will get into how to handle missing data, which is typical in most data sets. They're usually dirty and they don't have complete data. A lot of times you'll notice in some of the exercises we'll just omit those records completely, or we might actually try to replace them with something that seems reasonable in order to keep that data. We can also do something called normalizing. We'll talk more about this later on as well in the course, where you can kind of get something that has a very wide range of values down to a more normalized amount, a smaller range, and there's a way by which we do that in Excel Miner. The other problem that we'll talk a lot about during this class is the problem of overfitting. So many times we can be trying to produce a model that's so accurate that it is only accurate for the data that we have. So we may have this data set and it fits it 100% and it looks great, but then the minute you add new data and test it, to see how accurate is it, it just plummets.